It's hard to analyze data when it's siloed. So we've extended OpenSearch Analytics to Amazon CloudWatch Logs and Amazon Security Lake. Now you can get operational and security insights without duplicating data. Unified data with real-time insights. Simplified.
Hello, welcome everybody. Building agentic systems is really the trend these days. And agentic AI is really helping customers build amazing systems to solve really complex problems through innovative solutions. We see customers building agentic applications all the time. However, it's really, really important to monitor those systems. In order to monitor those systems, you really need to have a modern system for you to monitor applications that have agentic systems in place. Welcome to the AWS Cloud Operations Show. My name is Emaya Kumar Jagannathan. I lead the team, a team of solution architects, worldwide solution architects. We focus on cloud operations at AWS. And this is episode 16. I'm glad you're here, and I'm very happy to see you all here. Quick shout out on people who are watching online. Please be interactive. We'll have a lot of questions to. We'll take a lot of time to answer your questions. Make it an interactive show. Well, I cannot do this all by myself for obvious reasons. I do have amazing colleagues here on this show today, and they're all geared up to discuss all about agentic AI monitoring with Amazon CloudWatch. Let's bring them on. There you go. So maybe I'll remove. All right. It's always nice to have a little bit of trouble in the live stream. Folks, Ravi and Ila, thank you so much for joining. And can you introduce yourselves, please?
Sure, I'll go first. Hey, everyone, this is Ravi Tejasankoli. I'm a senior solutions architect with the CloudOps team. I work with Emaya, and I specifically focus on observability and incident management. Nice to meet you all.
Hey, Ravi. Yeah, nice to meet you all. Hey, Emaya, thank you for having me here. It's a pleasure here. I think it's the fourth time I am doing a live stream, so in Containers from Couch and CloudOps show. So thank you for having me here. I'll introduce myself again. My name is Ilamaran Shanmugam. I go by Ila. I'm a senior specialist containers solutions architect with AWS. I focus specifically on containers and AppMod domain. I currently serve my global financial services customers focused on agentic AI, platform engineering on EKS, and helping them to migrate their workloads from on-prem to EKS and ECS. Happy to be here.
Fantastic. We have assembled some amazing folks here today, and you guys are all excited about this topic, right? This is really not only us, but we can see from our customer interactions that it is a very powerful tool. AI is to solve very complex problems, right? And one of the most interesting ways to solve these problems is to create agents that can take actions on for specific tasks, and they can even work together to take really complex actions, so they can orchestrate themselves as well. But in order to do that, when you create a lot of these things, they can be running around and they can be doing things that you may not that you may want to keep a tab on, right? How they are performing and who's interacting with them, and like whether you've provisioned enough capacity for them and all that stuff. Because with great power comes great responsibility. All right. Before we talk too much about this, but let's let everybody on the same plane, and let's understand what we even mean by agentic AI. Ila, maybe can you give us an overview and set the stage for us, please?
Sure, absolutely. Do you mind sharing the screen, Emaya?
Yep.
Okay, awesome. Let's take a step back and understand. Before we understand what is agentic AI, let's take a step back and understand the microservices world, right? So just a fun picture here, right? This is the real-time graph of microservices dependencies at Amazon.com. See the complexity there, right? Like so many microservices running at par, and this increases the complexity. And by the way, this is 17 years ago. Now it is 2025, and understand now the complexity is going to be. It's going to be 10 times, 20 times more for the organizations, depending upon the size and complexity of the services they provide. So with that said, right, let's try to understand why agentic AI is important, and basically what is agentic AI. So agentic AI is fundamentally AI systems that can autonomously make decisions take actions on a human behalf, right? Which means that they're going to do specific tasks for you, and that is important to automation and other important aspects. So talking to so many different customers in the field, right, there are three different reasons why organizations choose agentic AI in this current trend. The first is enhanced decision making. They want these agents to take a lot of data, consider multiple scenarios, and make decisions as quickly as fast possible and more accurately as humans can do. And the second important thing is automation of complex tasks. So when I say automation of complex tasks, it has to be multi-step processes without any human intervention, right? So they wanted that also be a part of agentic AI workflows. And last but not the least is adaptability, right? They wanted these agents to be adaptable to the environment, adaptable to changing conditions in the environment, and then improve their performance over time. So which means that understand the complexity here. Like the world of microservices was there, it's still there, but now with agentic AI, the environment is super, super complex. So even though it was important that you have observability always, with agentic AI, the emphasis of observability is very, very important, right? Because you don't know whether the agent is like talking to the right agents, having the right permissions. You want to understand the transparency of the agents. You want to understand the control of whether they're maintaining the control, whether they're talking to right services, whether they're talking to the right agents in the right way, right? You need to really understand that. And that is where we need to have robust observability services in place in these environments. So take a look into this particular picture, right? It's a simple multi-agent system where you have multiple agents orchestrating. Yeah, you have an orchestrator agent talking to a weather agent, which calls an API. You have a city mapper agent talking to other APIs and also other MCP servers. So end of the day, there is a lot of interaction. You're also interacting with LLMs for interactions, right? So which means a lot of complex communication is happening. So where you need to have transparency, control, and you need to also understand whether these AI agents are making the right decision. And that is where observability forms the key factor. So that is what I can say about AI agents, Emaya.
Sounds good. Sounds good. So, Ravi, so the AI agents can get complex. I mean, if you have just one agent, that's one thing. We have as you can see on this architecture diagram, you can have multiple agents that can which can be orchestrated to perform a much more complex task and maybe solve a much more complex business problem. Is there anything that you want to add to it, like in terms of like how we can observe these agents and like why observability is important? Maybe set that expectation first.
Sure, yeah, definitely. Right. First of all, right, let me highlight like 4 key areas why the observability is critical for AI agents, right? The first thing is these agents follow non-deterministic control flows, meaning like their actions are driven by model reasoning. Like imagine like unlike traditional applications, which they follow the predictable path, the AI agents can take like different approaches to solve the same problem. So that's
So
the biggest issue.
what you're saying is in typical, if you take like a microservice, there is an if condition, there is an else path, if path,
Exactly. Yeah.
and there are 2 paths. Maybe there's a third path if there is an exception. Oversimplifying it, obviously. But agents, because they're non-deterministic, they can take any path, and that introduces another dimension here.
Exactly. Yeah. Yeah. And the second issue is like when in terms of root cause analysis in these agent models, right, becomes particularly challenging. Right. Like think about debugging a complex sequence of chain calls where each step could have multiple possible paths. Right. So without proper observability, this becomes nearly impossible. The third thing is we need to access the system and holistically. It's not just about the individual components, but it's really understanding how everything works together to deliver the intended outcomes. And finally, again, there is the critical need to detect the performance degradation early. Like I don't want Alice to go to a vacation and see that, hey, it's raining. You need to know what's really going on beforehand. So we need, and if the weather agent is not performing well, the total plans for a particular end customer would be in a failure, right? So as this system scales, being able to spot and address the performance issues quickly becomes essential. So that's where we have introduced Amazon CloudWatch Generative AI Observability at the New York Summit a couple of months back, which we're going to explore in detail today. So I'm going to give you a quick intro to the audience here, what exactly this feature is. It offers curated insights with out of the box dashboards. Like we offer 2 out of the box dashboards. One is model invocations, which gives you the detailed metrics on model usage, token consumption, and the cost. The other dashboard is Amazon BedRock AgentCore Observability, where you can have a detailed performance and decision metrics for the agents, the key metrics including average invocations, token usage, latency, error rates, throttling, and details into the prompts that user passed on to the agents, right? All these things you can have out of the out of the box dashboard.
So just
And
well, you mentioned two important points, I think, for those if they're not clear about this concept yet. An agent is essentially, let's say, I mean, in the rough terms, it's just a microservice that has that's built on a specific SDK that is designed to build agents, and it itself does not have the model in itself. That is just an application that is going to make calls to a model that is hosted elsewhere. It could be BedRock, it could be anywhere. And what you're talking about in this is you're talking about monitoring performance from the agent, and also there are telemetry that the model itself would emit in terms of its own invocation, because agents are calling those models based on user interaction, and that also, right, model performance and the agent performance.
Exactly. And one more thing, when we talk about microservices, so you would see a lot of microservices will be embedded into this agent workflows, right? So you need to have observability into those as well. So we're going to have an integrated experience where you can monitor agents, monitor the model, and you can also monitor your microservices all within a single pane of glass. So that's the experience we are providing with this one. At the same time, we are providing the 360-degree view of your agent. It means like whether you are using BedRock or different models on elsewhere, or whether they are built with different frameworks like Strands, CrewAI, or LangChain. It doesn't matter which framework or where you host them. You can monitor all your agents right from this console. And all this can happen without changing a single line of your code. So we have something called auto instrumentation agents that we provide, which is like AWS distro for OpenTelemetry. You can use this, and you don't need to have any additional collectors to collect the telemetry from the application itself. You can start the auto instrumentation and send it back to the CloudWatch. So as easy as that. Once that is done, you can also do the end-to-end prompt tracing, like when the agent is calling LLMs, if it's calling knowledge bases, or if it's calling microservices, you can view all the details, what are the prompts, the messages that it is calling with. And also the most important piece in these agentic workflows is sensitive data, protecting the PII. So we have a feature to mask the sensitive data as well using this feature. And in terms of supportability, we have two ways, like to monitor, configure the monitoring. One is on the AgentCore. Let's say if you deploy your agents on AgentCore. Again, for the audience who are new here, our AgentCore is a new runtime, which is a secure and serverless. It's a purpose built for deploying and scaling your agents dynamically. That's a new runtime. If you deploy it or agents here, you can use the same CloudWatch GenAI Observability to kind of monitor it. Or else, if you have existing agents, might be running on EKS, ECS, Lambda, or even on-prem, right? You can use the same observability dashboard to monitor agents. That being said, let's go ahead and talk about the kind of architecture that we're going to demo here. I know Ila shared a multi-agent approach where you have an orchestrated agent, which is calling the weather agent, which is calling the map agent, right? So for this demo, I'm going to build a simple weather forecast agent and add the observability and kind of monitoring the agentic performance on the new dashboard.
That's great. So we are getting the hands-on part of the session now. You're going to show us exactly how to build something, and okay, that's great. That's exciting.
Yeah. So this is the high-level architecture where for this demo, I'm going to use a Strands agent. It's an open source SDK provided by Amazon. So this Strands agent going to call a BedRock model, which is I'm going to use today would be Claude Sonnet 4. And since I'm building a weather forecaster, my agent needs to call to a real weather API to fetch the current weather information. So I'm going to call weather API using a Strands inbuilt tool called HTTP request. And once it is done, I'm going to add the observability with the help of our a.sdk and auto instrument it. Oops, my bad. Give me 1 second. Yeah. And then send it back to the Amazon CloudWatch. Yeah, that's what I'm going to show today.
Fantastic. I'm looking forward to that.
There you go. Let's go ahead and start building the agent here. What I'm going to do, I'm going to quickly create a virtual environment for my project here.
Could you make the font a little bit bigger? Maybe zoom in, like Command plus a little bit?
Yeah. Now?
Yeah, that's better. Yeah.
Perfect. Yeah. So I'm going to install a couple of Strands packages for us to build. One is Strands agent with OTel, which means it can export the telemetry in the form of open telemetry. So that is the one package, and that is the Strands agent tools, where we're going to import our HTTP request tool from here. So I'm going to import these two packages here.
So a quick overview on what Strands itself is. It is an open source SDK developed by AWS. And when I say open source, it's open source. Like we have it out there. Like there can be contributors, I guess, right? And that is specifically designed for building agents, and it comes with observability, I guess. Like that's the open telemetry part of it, and it natively has a lot of tools as well, like HTTP tools, like all those like capabilities, different capabilities. The technical term is tools for the agents to make to be more useful, right? Talking to databases, to talk to other HTTP endpoints, and making calls to MCP servers, and so on.
And then exactly is it also can support different model providers. BedRock is a default model provider, but it can also integrate with other cloud model providers as well. So that's the beauty of Strands being open source.
That's fantastic. So you can actually take it's truly open source, and it's not like it's not just something proprietary here. It's out there. It's all Python based. It's Python SDK. People can take it, use the Strands SDK, build applications, deploy, use any model anywhere, and just play with it.
Yeah, and along with that, let's say if you have your AWS environments, you can call our MCP servers and directly build your own agents in terms of troubleshooting or whatever. You can do much more with Strands, build multi-agent workflows, right? It supports pretty much everything. So let's go ahead and start building our sample Strands agent here, right? So I'm going to import an agent class from the Strands, and for my HTTP tool, I'm going to call HTTP request tool. I'm going to import these two.
So that's the one that is allowing the agent to make remote calls, right? Like so
exactly.
It can information and like I said, just be more useful.
Exactly. And then I'm going to call Strands model. So if you just to and I'm from Strands model, I'm going to call BedRock. Without this, the default would be Cloud Sonnet 4. If you want to change the model in the BedRock, you can use the BedRock model class to do that. Once you import it, it's pretty straightforward. You can call my weather agent class, for example. I can do it right now. And add the parameters. The first parameter would be the system prompt. Just to let you know, the people here, if you are new to the building agent, system prompt is kind of a job description that you give to agent to let it know what exactly it needs to perform when a user provides a user input, right? So that would be my system prompt here. I'm going to input my system prompt.
Essentially, you're drawing a lane, so it doesn't veer off, right? Like you're giving it setting a scope, in other words.
Exactly. I'm going to save my system prompt in a separate variable here. I'm going to show you real quick how my system prompt looks like.
What is this editor you are using?
Oh, it's a new Kiro.
Awesome.
So you can look at my prompt, right? I'm letting the agent know, hey, you are a weather assistant. You have your HTTP capabilities where you can make a request to National Weather API. And this is the API. And this is the format it needs to call the weather API. And then once it receives the data, process it, and provide the information in a certain format, right? I'm asking it like, okay, when displaying responses, highlight important info like temperature, precipitation, and alerts. And I'm pretty much, I'm instructing the agent to behave in a certain way using the system prompt. So I'm going to call it from here. And then next, I'm going to import my HTTP request tool here. And then the model. So if you don't specify this model, by default, it uses the latest Claude Sonnet 4 US West 2 region. But let's say you have a model in a different region, you can define it using the BedRock class that we defined earlier, right? I'm going to do that real quick because my model is in US East 1.
And you can also import your own model to BedRock, and you can also use your own model as well in this orchestration.
Exactly. Yeah, it not necessarily be BedRock. If you have something in OpenAI or Anthropic or anything, right? You can import the same thing. And then I'm going to add my model ID. So again, I'm going to use Claude Sonnet 4 for our demo real quick. And then the region would be US East 1. That's it. And once you define this, I'm going to call it inside this class.
And because you're going to deploy it, if you deploy it in the whatever runtime you're deploying, obviously that needs to have permissions. That is not necessarily in the code, that is outside of it. So just to be clear on that, right? Yeah.
Yeah, exactly. I'm going to go to that in a moment. So once that is done, let's call the agent here. Okay, I'm going to clear it out. It's pretty simple. Agent. Oh, I have defined this one with agent. And you can pass your prompt. Let's say I'm in Seattle, so I want to know how is the weather in Seattle today. That's it. I'm going to save this file. It's an app1.py. And I'm going to call it from my terminal. Python. It's as simple as that. Okay, I need to be in this directory.
Yeah, maybe you didn't save in that same.
No.
Oh, your prompt is not in the same one. Okay, your terminal.
Yeah, and in a different folder. I'm going to activate it, my virtual environment.
So now you're running it locally, right?
Yes, I'm going to run it locally. Yeah.
Mm-hmm.
So what happens behind the scenes? It's unable to look at credentials. So I didn't have my credentials saved. Oh, wait, I think it's in this one. Sorry. I have my credentials here. I'm going to run this app here. Basically, since it's calling.
Maybe you just need to refresh your credentials.
Yeah, give me 1 second real quick. There you go. Done. They should work now. Okay, so there is no module called Strands, maybe a spelling mistake.
Is there a...
Oh, wait, I'm not in my virtual environment. My bad. So after credentials,
good to learn all of these things, right?
Exactly. Yeah. Right. Yeah.
I love it.
This is where I have installed my Strands packages. So there you go. Now it starts in the background. The agent will call the Claude. The Claude will decide like what to do. Now, what Claude is doing is it's calling a HTTP request tool with the grid information, and it's giving me all the details, how it looks like. You can see, hey, Thursday, September 25th, in Seattle, it's high 64, partly sunny, right? So I just made a simple app using Strands within minutes.
Okay, this is one of those very rare days where you have a very low chance of raining. That's
yeah.
That's good. This is really cool. I love it.
Exactly. And again, if you can make an interactive app, you can host it in a runtime, and then maybe have some microservice call it, right? Where maybe a front end call it. You can make all such cool things.
Awesome. So where is the observability part of it?
So I'm going to show it. First, let me deploy it to the AgentCore, and then I'm going to show you how to add the observability piece to it, right? So let me clear it out. To make this compatible with the agent on core, I'm going to show another app here, the same thing. Couple of things that you need to do is first import this BedRock AgentCore app from this runtime module. That's the first thing. And once it is done, you initialize the app and then add an entry point, kind of a decorator to your invoke function, and add app.run, which you are letting the AgentCore runtime like control the running of the agent, right? So these are the three things you need to make sure to add to your app to be able to deploy it to the AgentCore runtime. And to deploy it, there are a couple ways. One, using a starter toolkit. It's pretty straightforward, where the starter toolkit can prepare the Docker images and deploy it to the runtime directly, or else you can customize it. You can prepare your own Docker images. You can push it to your ECR repository and then deploy it to the runtime. So the things I'm going to do is pretty much this shows here. The starter kit, once you configure it, this is what we have done. We have prepared our agent. We have prepared like Strands, demolish Claude, and I added our runtime decorator, which is this. Once that is done, I'm going to use the starter toolkit. So for that, I'm going to install my starter toolkit. So this is pip install.
Did we lose Ravi? Looks like
Yeah.
we have some internet issues with Ravi. So okay, no,
I'm back. I don't know, like I didn't even know that I lost you guys. Okay. Cool. So I'm talking about the architecture diagram, like how the BedRock starter toolkit gonna deploy the agent to the runtime with observability enabled. So this is the thing that we have done so far with a model which is Claude, the framework is Strands, and we added our runtime decorator, which is the entry point. And then we're configuring the starter toolkit. I just installed a starter toolkit. I'm gonna configure it real quick. So it's a pretty simple command. Okay, so the command is AgentCore configure, and your entry point is my agent.py. And I'm giving it a name called, my agent name is Strands, like AgentCore, just to distinguish. And then the region I'm deploying is US East 1. And then my ARN, like this has a certain permissions for the BedRock AgentCore runtime to push it to the CloudWatch, push the telemetry to the CloudWatch. That's it. Once you do it, it will ask you for a ECR repository. If you have one, you can mention it. Otherwise, I'll let it create. I do have one, so I'm going to mention my ECR repository. And then dependency file, which dependencies you need to install. So it automatically picks up the requirement files within the current folder. If not, you can mention your own file. If you look at the requirements file, so there is like 5 requirements. One is the BedRock AgentCore itself, which is necessary for you to deploy. And the other 2 is the framework that you're using. Right now, I'm using Strands. If you have a LangChain or CrewAI, those are the frameworks that you need to use to deploy. The 4th one, this is the important piece. This is our auto instrumentation agent, which we're going to deploy. Once you add it, the BedRock AgentCore going to take care of everything for in terms of observability. You don't need to do anything. The only piece you need to add for your observability is this. No need to change any code. Just add this requirement. And when the app is initialized, this kind of acts as does a monkey patching, where it can intercept the agent calls, adds the required spans and like telemetry and everything, and can export it back to the CloudWatch. It's
Awesome.
as easy as that.
Right. So we talk about single click deployment, and this, with what you just explained to me, there is not even a single click here. You just add the AWS OpenTelemetry distro
That's
dependent
it. Yeah.
requirements file, and that injects itself into the application's runtime, captures what it needs to capture in terms of like spans and even logs, is it? Or just only spans?
Yeah, spans and span logs. Yep, both.
Okay.
Yeah,
And sends everything to CloudWatch.
exactly. Yeah. So you can
Right.
see now that the starter kit is you can see the Docker file it created and what's the command it's running. So this is the command which actually intercepts the calls, like open telemetry instrument. Like usually what we do is like Python and agent.py. That's the command we call. The only thing that needs to be preceding is the open telemetry instruments, which directs the ADOT to auto instrument and kind of intercept the call and collect the telemetry and push it back to the CloudWatch. It's done automatically in the AgentCore. You don't need to take care of anything else. It's pretty much inbuilt. While this is being done, I want to showcase how the GenAI console looks like. I do have a pre-sample data while this is being installed.
And now you deployed it to BedRock AgentCore, right?
Yes, yeah.
That's what it is. And okay, that's the fully managed runtime just for agents from BedRock.
Exactly. I'm going to show you quickly how the agent looks like here. So this is a runtime core, and this is the agent runtime, and this is my agent. That's it. You can it's pretty much in there. You can invoke it using Boto3 or endpoint. I'm going to show you how to invoke that in a moment once it is deployed completely.
I can even create like an application, like a web app, because this could very well be a chat application. I could just write a web application just to make HTTP call, and that's it, right?
Exactly. And also there are like multiple tools like memory management, like you don't need to worry about managing the infrastructure to maintain that context-aware application. So you can just like create the memory for your application and it takes care of the rest for you.
Fantastic.
And again, identity, right?
Yeah, let's go to CloudWatch and see what kind of telemetry it collected.
So yeah, this is a new feature that we launched. Right now it's in preview. So these are the two dashboards I'm talking about. One is the model invocation, where you can see all the invocation details about BedRock model. So there are a couple prerequisites you need to enable for this data to be showing up. One is a BedRock model invocation logging. This first step is specific to BedRock models. So for that, you need to enable BedRock model invocations in the BedRock console. And the second thing is the transaction search. Since we are exporting the telemetry in the form of open telemetry to our CloudWatch OTel endpoints, customers need to enable transaction search so that we can ingest the data in the open telemetry format. So it's under the settings under the transaction search here. So right now I enabled it. That's all you need to do. Only two prerequisites for the data to be showing up here.
Fantastic. So it says all model ID and then it says all. If I used multiple agents and then they all use their own models.
Yeah.
Be able to see all the models there, right? Like all the names of the models. And then it could be like Sonnet 4.1 and then Sonnet 4, Sonnet 3.7, whatever that is. And I'll be able to filter just that data and visualize and kind of get the model performance.
Exactly. So this gives you the time series graphs on the count, invocation latency, tokens, right? And the throttles and everything. If you scroll down a little bit, it will give you details of each invocation with a request ID. So you can see the input token, output token, latency, and what's the model ID being used. So if you click on a particular request ID, it will give you the model invocation input, whatever the text that you inputted, and the output of the model. So
this
pretty much
text that inputted, you're talking about the prompt, the user's
yes,
prompt, right?
Prompt,
okay.
Yeah.
Okay. And with that, if I'm troubleshooting something, and I can always go find out, okay, what was the user asking, and whether that, how did the model respond to that prompt, and what did the agent do with that response, and then maybe it did something else, and then maybe it had to make an HTTP call. I can see all of those things here.
So that one you can see in this BedRock AgentCore. The first one, it's specific to the model, like all the other interactions the agent is making, it's specific to this one. If you click on this, we have three views. One is agent view that you're talking about, like what are the agents that we have? For example, I do have a bunch of agents on BedRock AgentCore on ECS, EKS, and maybe my locally I'm running my agent, right? You will see all the agents here, and you'll see all the sessions that were run on that agents, like sessions kind of interactions. a bunch of interactions, and traces is a kind of interaction to made to an agent. So you will see all these details. And let's say I want to look into one of the sessions, like go into my local dev, sessions. You can pick up a one particular session ID. You will see the interactions that made during the session ID. You can click on that particular trace. So which will give you a trajectory map on how the agent, what actions that agent took to give you the response back. For example, in my case, I have a Strands. There are 3 times that agent went to and fro. So I have 3 event loop cycles. In the first loop cycle, agent interacted with my model, and model requested for information from the weather API. So that's why it went back to request to the tool, and the tool gave answer, and agent again requested, hey, this is what the HTTP request tool gave with the weather forecast. Now process it. And it needed some more information. So again, it called one more API, and then finally it processed. So you can see all the loops, all the interactions in a visually. And let's say if you click on one particular model, you can see all the metadata, what the ADOT SDK is bringing in. Like, for example, what's your service? What's the remote operation name, request ID? And pretty much there are a lot of parameters. Specifically, if you want to see the prompt, we are saving it in terms of span events. You can expand is one of the event. For example, the system message, the weather assistant. You can see it here.
That's a system you gave, right?
Yeah, I gave in my code in the agent.
Right.
And let's say you want to view the user message, what the user asked. Like I asked, okay, what's the weather like in San Francisco? So you can view that in a user prompt in all the details in this flow.
This is awesome. So this is really purpose built for this use case, for this scenario, and gives me all the details, enriched information in the span, which is really useful for me to troubleshoot. Right, this is exactly what I want when I'm troubleshooting something like an agent, and which is quite different from just a microservice alone, because that can be on some, you don't necessarily track sessions, for example, in a microservice, because you expect that to be stateless. But here that has changed, and you have state that has to be maintained and all that, which is great. Okay, awesome, thank you. I know Ila has been quiet a little bit, but he's written at least 2 books. I don't know about Kubernetes. I don't know how many more he's written, and I'm sure he's excited about this, and he has something on to show about Kubernetes as well, right? Because we initially mentioned that you can build an agent that you can throw it on anywhere you want. BedRock AgentCore is the easiest and fully managed environment that you can just throw in the fire and forget, sort of. But if you're a Kubernetes person, if you like to have a lot of control, if you want to have a lot of customization stuff, you probably want to do it yourself in an environment like a container environment or EC2, whatever. Eli, is that something that you're excited about?
Very excited about. I can talk about a couple of things here. One is I want to talk about how you can deploy this same technology and same methodology which Ravi talked about in EKS, and I will also show a similar demo with how you can do it in ECS as well. So what Ravi was showing so far is the weather agent, which is invoking a weather API to get us the real weather for Seattle. Now let's switch gears and talk about a city mapper agent, where the agent is basically going to map let's say you're going to ask the agent, hey, what are the famous restaurants in some place, or what is the famous thing that you can do in Tokyo or Paris, right? The city mapper agent is going to do that. So that is what I'm going to show in demo right now. Instead of Strands, which is it's very popular and everybody is using Strands, right? I want to also use another popular framework that is being used for agent building, which is called LangGraph. So this is basically, you can see my code, right? I just wrote this prototype basically using LangGraph. So what we are using here is LangChain. So LangChain is basically a method to orchestrate LLM. So, Ravi was showing a method to use Strands to access BedRock as the model provider, and using Claude, right? So here we are using LangChain for same purpose. And here also you're using BedRock as the model provider, but LangChain is the LLM orchestrator. And likewise, we are using LangGraph here. So LangGraph is basically the package that we are using here for LLM state orchestration, like state messaging or messaging between the LLM, right? You're going to have some package to really manage that state of messaging, and that is what we are going to use LangGraph. And then also we are using Langsmith here. So in Langsmith with OTel is going to provide you that instrumentation and that telemetry data that we're going to get from the agents to really understand what's happening under the hood. So basically, this Langsmith with OTel enabled is what is actually making the magic here. And for this particular demo, right, we are using DuckDuckGo. So DuckDuckGo is like, it's like Google. DuckDuckGo is another private search engine that can get you the data that you're looking for. Let's say you can call this API to get famous destinations and famous things. It's going to get you that privatized search, and we are using that as an agent tool here. If you see, this is the code that we have written. It's a very simple, like 10, 20, 15 line code to use DuckDuckGo. DDGS is the library that I have, imported here. It's an external tool. And then obviously I'm using that for the web search here. And
well,
then,
I had no idea. There was an endpoint that you could use DuckDuckGo with. That's interesting.
Yeah, I learned it yesterday actually. But yeah, it is very interesting. Yeah. But yeah, again, I'm getting the same thing that Ravi was showing. I'm using the LLM setup here, which is basically Claude in this case. I'm using BedRock as the model provider. And obviously, you can set up few other parameters like temperature and other things as part of the model LLM configuration setup. And then obviously, I'm using the graph builder to basically have that conversation state going on with the LLM and the interaction using the LangGraph. And then this is my agent code, similar to what Ravi was building, right? Obviously, I'm just saying, hey, this is my protocol. Like I'm a travel agent. I can take real queries and I can return you the dictionary of all the things that you're looking for based on my interaction with other tools that I have, right?
Is that a
So
system prompt, like Ravi said in a system prompt in the model?
Yes.
That's the one?
Yes, that's a system prompt. Yes.
I see.
That's
Okay.
prompt. Yeah. And then obviously, this is something we are also adding to this, right? Basically, it is called baggage. So what we want to do is, we wanted to also manage the session of, let's say the agent is invoked by multiple sessions, right? We also want to manage the session and see that in CloudWatch console. And that is where we're using this OTel baggage import. And then we're maintaining the context of that particular session through the OTel context baggage. And then obviously we are actually setting that as part of the agent invocation through a unique identifier in session. And then obviously we are invoking the agent, right? And then as part of startup, I'm just giving some basic information to the user to say, hey, this is a travel agent. And these are all the questions you can ask the travel agent. This is the prompt for the agent, but this is a new information that you're giving to the user when they invoke the agent. Right?
That is just an SPDR, just for users. Just set the context to the user what this agent can or cannot do. Okay.
Exactly. So that is with respect to the code part, right? I'm using LangGraph here. And then in terms of the requirements, similar requirements to what Ravi had, but I'm also having the different packages that I mentioned. LangChain, LangGraph, Langsmith for OTel, and LangChain Community, DDGS for DuckDuckGo private search engine, then OpenTelemetry for LangChain, and this is the killer. This is what is going to help us with the auto instrumentation. And then with respect to Dockerfile, right, here is where the real tinkering happens in ECS and EKS environments, right? This is not what Ravi was doing, but I have to do this to make it work in EKS and ECS, where I need to have these environment variables configured. I can configure this as part of my deployment YAML, but I also try to do that as part of my Docker image, where I'm trying to give all the different OTel instrumentation requirement variables, where what kind of traces exporter I need to use, log exporter I need to use. I'm giving all those combination, what is the exporter header, and things like that, right? I'm just giving those necessary variables as part of the setup. And then once you run this, it should do the magic. And this is my deployment, nothing really fancy. I have a service account, basically through an IRSA process, which can access BedRock, because my deployment part needs to access BedRock, and then only it can do that LLM. Correct. So
right.
that is why
which is the one that I was talking about initially, I guess, right? So where this is wherever the compute is, it just needs to have access to those models and have access to BedRock to begin with, and then have access to that particular model permissions, so it can make those calls. Got it.
Exactly. Thank you, Maya. Yeah, I mean, and also, right? Regular deployment. Anybody with basic Kubernetes knowledge should know this. Like, you just have a deployment for travel agent. Just for the benefit of the demo, I have already deployed this. So let me jump into the terminal and show you in action. So let's see here. So
Yeah.
obviously,
Sorry, while Ella, you're talking about it, just want to highlight one thing in the environment variables. Can you open the environment variables real quick?
of course, yeah.
Just wanted to highlight the difference between the agent core and the rest of the platform is if you see the line number 24, the agent observability enabled. So that is where it's triggering the ADOT pipeline, which is very important. And the rest of the modules are like configured a way to send the data. Like for example, the first Python distro. So when you install the OpenTelemetry, it will have the upstream as well as the AWS modules. So this is where you're configuring, hey, just send the data, use the AWS distro, and the AWS configurator gonna kind of enrich the metadata, kind of adds like AWS related info, region, cloud ID, instance ID, like maybe EKS pod, all that information, and send it to our OTel pain points and kind of the headers and the logs where you need to send the data to. So the real magic happens like when the line 24 where you set it to true and trigger that ADOT pipeline. Within the agent core, you don't need to do anything because it's already built in. Yeah, that's a subtle difference when agent core is EKS.
Yeah, exactly. Thank you for pointing that out, Ravi. Yeah, that's exactly the killer here. Along with the requirements like auto instrumenting package, along with this particular line number 24, does the real magic. So yeah, thank you for pointing that out. Okay, so let's jump into action and show you how it actually works. So I already have deployed this agent. It's already, you see it's running fine. So let's exec into the pod for the demonstration purpose and see what I'm going to do is, obviously, this is what Ravi also mentioned, right? We need to have open telemetry instrument appended along with the Python run of that particular Python agent, like the agent that is written in Python, so that the auto instrumentation really happens along with the orchestration of the agent. So that's what I'm going to do here. It might take a couple of seconds for the agent to come. And obviously, this is what I was showing in the main, right? Maya, you asked it, right? So we are just giving this information to the user. So what I'm just trying to say here is, what are the best restaurants in Chennai? So basically, I'm from Chennai, so I'm just trying to ask that question to the agent. Let's see how it responds.
And is this also using BedRock Sonnet model? Is it?
Yes.
Okay. Got it.
So obviously, you see, right, it gave some famous restaurants in Chennai, but it was pretty quick, right? It was pretty quick. So now I'll answer Imaya's question again. I'll show you in action. We are actually, yes, using BedRock's model here. Yeah, here it is, right? We're using this Anthropic Claude 3.5 Sonnet model, and the model provider is BedRock. And if it is a different model provider or a different model, we change it here. Okay, let's go to the CloudWatch console and let's see what's happening. It is going to be pretty similar to what Ravi was showing, but I'm just showing this from the perspective of EKS because we can still hack it for EKS also. But you might be seeing that it shows it is BedRock AgentCore. If I click on BedRock AgentCore, but still I am wiring that through those variables that we discussed. I'm able to see that agent really extrapolated here through CloudWatch. So let's click on the LangGraph travel agent here. And obviously, you see, right, it can show some metrics around, it shows that there is one session that is running and there is one trace. And if I click on sessions, obviously, it is showing me the session that we invoked. And obviously, if I click on traces and if I click on trajectory, it is going to show me the trajectory of my agent, right? It is basically a chatbot kind of an agent through LangGraph. And then it is obviously assuming the role through IRSA, which we spoke about. And then it is accessing BedRock. So this is the flow of actions here. And then from a timeline perspective also, it is going to be similar. And then you will also see all the metadata of the invocation of that particular thread, the span of that particular thread. You will see all the information here. Telemetry version, the SDK that we used, and so on and so forth. And then obviously, if I flip back to the BedRock invocation, I can see similar metrics, right, which Ravi showed. Invocation count, latency, tokens per the model, and so on and so forth. Let me see within this time. I do think I might be seeing this. See, yeah, what are the best restaurants in Chennai, India. It is able to give me the response, and it is also logged as part of the invocation.
That's
So-
fantastic. This is basically the prompt that you asked, right?
Yes, exactly. I will also try to show something different here, right? Like, and this is EKS. Obviously, we try to went through the Kubernetes native way to get this deployed, but I want to also show how we can deploy this in ECS also, because ECS is also a primary customer for us in terms of container orchestration, right? So EKS, a lot of customers use. So let's also see it in ECS as well. So for ECS, what I'm using is I'm using the same code which Ravi was writing, similar code. I'm using Strands, by the way. I'm just using this for I just dummied out weather because I just have it as a custom tool. But obviously, I'm having BedRock model, and then my agent is calculator and weather. Calculator is a default tool that you can get from Strands. And then this is my agent. Obviously, I'm using some trace attributes for tracing and things like that. But it's a very simple agent. It is just going to do some calculation and provide you that response for calculation.
The agent code itself doesn't have anything to do with the environment it is running. There's no tie-up with this agent code and ECS here, right? Correct. What you're showing is explaining the capabilities of the agent, but not necessarily anything specific to ECS yet.
Yes, nothing specific to ECS yet. You're absolutely right. So, I mean, similar Docker file. I don't want to go into all the variables and all the environment variables in the Docker file, but nothing really specific other than the environment variables that you need for agentic instrumentation through OTel, and then obviously sending the metrics and traces to the OLTP endpoint for CloudWatch. Nothing else is different here. In terms of deploying it through ECS, what you have to really do is it's very simple, right? I mean, if you have done ECS deployments, it's pretty simple. All you have to do is have all the things that is tied together, and then when you are really deploying the agent, you just need to have that ECS task with a task definition. It says, hey, what is the task role? What is the ARN? Obviously, in task role, I should have a task role which has access to BedRock, because BedRock is the orchestrator here. And then obviously, I need to have access to AWS logs. And then in terms of the variables that I talked about in the other example, I can also punch in the variables through the environment. If you are not comfortable in passing those environment variables through Docker file, I mean, obviously, passing it through Docker file is not a great way of doing it, not the best practice. But from a POC perspective, I was doing it. But for this demo, you can also use the environment variables to pass all the specific variables that is required for the task to run fine. So in this example, I'm also using a load balancer, but it's a very simple detail here. I'm using a service, ECS service here. I will also show you, I mean, this is already deployed, because for the benefit of the time, this is already deployed. It's already running. So this is my ECS cluster. And then obviously this is my Strands agent service, which I deployed through the YAML. And then this is my task. My tasks are running here fine, no issues. So one other thing that I did here for my tasks is I enabled exec. So if I go to my configuration.
So you can go into the container and kind of invoke that. Right?
Correct.
So Ila, I do have a question here. So you showed us on the ECS and EKS. Is it the same way you can do it on, let's say, you are having your own Kubernetes cluster on on-prem? Can you do the same thing?
Absolutely, you can do the same thing.
Okay.
All you have to do is you just need to have the role to access BedRock. That's the only thing that you need to worry about. And then access to the cloud API. That's it. Rest of the things are all same.
Got it. Yeah.
Great question. And then obviously I'm using the ECS exec enabled. And this is what is going to help us exec into the container that we have that is running in ECS, the task that is running in ECS. So what I'm going to do is from my console, let me get out of this. This is EKS, but let's get into ECS, AWS. So what I'm going to do is I'm going to use this ECS exec command. I'm just giving the cluster name. I'm giving the task name. I'm just giving the container name. I'm just giving the same command that we have been doing for some time now, which is the Open Telemetry Instrumentation, Python, and main.py. And the region is US West 2. So this
what I really like with ECS, you can actually do the exec from within the console, which I found only recently. And that's really cool. You do the same thing just right off the ECS console itself, which is amazing.
Yeah, the parity between Kubernetes and ECS, right? People say, hey, I can do exec in Kubernetes, why not in ECS? But yeah, you're right. So let's run a simple query. What is 99 divided by 9?
And this would, now you're asking a math question, and
Okay.
it is using the calculator tool because you configured in Strands agent. Hey, Strands agent, you can also use this tool. You allowed that to use. So it is basically using that to do this math.
Exactly. So that I mean that's the beauty of Strands, right? Strands is that's why Strands is getting very popular, right? It gives you those default tools which you don't need to create on your own. So I just gave calculator a single word. It is doing calculations for me. So
That's
all
nice.
right,
How many such tools exist? There are dozens of them, I guess.
it should be. Yeah, I don't have the number. It is evolving as every day. Should be at least
Sure.
dozen at this point, but it is evolving. And I'm also thinking of building a tool and actually contributing to Strands as well.
Awesome.
Okay.
That's amazing.
So yeah, I think I mean I can show this also in action quickly. Let's go to the CloudWatch console and let's go to BedRock AgentCore, and then I'm going to click on Strands Agent ECS, and that's the name of my agent. And then obviously I can see some invocations, right? I do see that there are one session that is there. It is showing me 3 traces because I have the interval as 3 hours. And you see here there are a couple of traces here. The latest one is at 2:55, which is exactly the time that we are at this point. So it's all good. The trajectory, and if I see the trajectory, it's going to be a little different. So obviously the chat is invoking LLM, and then it is invoking Strands. It is executing the tool calculator, which is within the Strands agent. And see the flow, right? It's awesome. It's basically interacting with LLM, and then also it is using its own tools to make the decision respond to the user based on the query from the user. Likewise, if you see the timeline here, and likewise you see the metadata here, and then obviously if I jump back to the BedRock invocation metrics, yes, I can see a lot of metrics here. Likewise, and then obviously if I'm going to go to the invocation, I will see this. Yeah, what is 99 divided by 9, right? So yeah, I think this comes to the full cycle, right, Imaya? We saw an AgentCore, we are seeing an EKS and ECS, and that's why this talk is agent observability anywhere.
Here's a question. So I know this is what makes me think is that people ask all kinds of questions. There could be even private information that people might be prompting agents with, right? Well, what if I want to sort of like mask those kind of things? Like I don't want people to like put in their credit card information and like, or maybe their address or phone number, whatever. But I don't want my operational people to be looking at that. How do I do that on CloudWatch? How do I hide that information?
I can talk about that, MIM. So most people, right, they want to infuse some kind of business context into your agent. For example, let's say, imagine the same multi-agent application Alice is calling a weather API or a Mapper API, right? So they might be adding business context like what is the user email, like what is the user ID. So all kind of things that they will be adding, but to mask it. So there is a way using the CloudWatch data protection policies. I can show you real quick.
Sounds good. Let me see if I can switch your view. There you go. You're on.
Yeah. Yeah, if you see the code, right? So what I'm doing is I'm passing, hey, whoever is calling, just add the user email, user ID, and some tags, right? But somehow, let's say if I don't want someone to view my user email, like I want to mask it out in my observability, like only admins can view, the rest of the engineers in my team doesn't want to do it. So this info is being dumped into AWS/Spans log group. All this, what you can do is you can set up a data protection policy, and we have um, managed identifier where you can mask address, AWS secret key, bank account, driver license. There are a bunch of managed identifiers where you can mask them, or else you can create your own custom identifier. If it is something related to business, you can add your custom identifier, mask it. And then once you go back to BedRock AgentCore, let's say I'm going to pick any one of the session here. I'm going to go back to 4 weeks real quick, pick a session. And click on it. So I don't have the user ID here. Let me pick another session which I might have a user ID real quick. Maybe this one. Yeah, there you go. So I'm adding the user into my span context, but there you go. I'm masking it using my data protection policy. That's how you protect your sensitive data being like exposed everywhere in your organization. So that's a
Yeah.
really important piece in this agentic world.
Absolutely. Yeah, absolutely. That is what I've been thinking since the beginning of the demo, because you guys were showing all
Yeah,
kinds of details that people are inputting, and I'm like, oh wow, this is going to be very exciting. When you're an operator, you'll be able to, there's a chance that there is private information that might get in, right? A
exactly.
much
Yeah.
higher chance compared to like traditional application monitoring. Okay, we're up against time. We're in fact 1 minute over.
Yeah.
This was amazing, and I think we can keep going for another couple hours. But this is awesome. Thank you both for being here. I think this was very useful for me. I learned a lot, and I'm hoping everybody watching also learned a lot. Thanks everyone for joining, and we'll see you all in 2 weeks' time. Thank you, Ravi and Ila.
Thank
Take care.
you. Take care. Bye.
Bye.